and then some slab panels are one way. You can see this is a one way, that's a two-way slab panel. Remember the failure mechanism for yield lines. Yield lines form at the boundaries of edges, and then they terminate at the boundaries of edges. They commence at the intersection between boundaries, and so on. These are properties of yield lines. So based on the yield line mechanism, the load will be transferred to the corresponding beams depending on the level of continuity. If you look at this slab panel, it is continuous in this direction, it is continuous here, it is discontinuous on this direction. So it is simply supported here, and then it's continuous and continuous here. Okay, so the yield line mechanism will be such that you have more loads on this beam and that beam, and lesser loads on that beam and that, because you have no restraints here and you have more restraints here. So STAAD will help you to calculate, to develop the yield line and transfer the loads to the beams correctly by using a specification in slab called floor load. So you go to floor load. So what happens in floor load is that you specify the pressure intensity. So let me explain this thing a little bit more in details. Okay, if you look here carefully, so these are the yield line. This is the mechanism for which loads are transferred from slab onto the beams based on the restraint, the continuity of the edges. This is a derivation of the corresponding yield line failure pattern for different slab continuities. So if you look at the key, you see that when a slab is unsupported, you have dashed line. When the slab is simply supported, you have it not too thick. When it is continuous, when you have a slab at the adjacent or the opposite end of the panel, you have it thick. So if you look at, once a slab is continuous, you have the yield lines. So yield lines comment, so there are properties, there are rules in forming yield lines. If you look at, I mentioned earlier on that yield lines must be straight, that the failure, that the lines in which the moment on the structure is maximum. So the rules for postulating yield lines for two-way slabs is that they change direction at the intersection of another yield line. So once a yield line meets another yield line, the direction changes, or it changes, as you can see in this instance. Yield lines are usually straight. Yield lines separate two elements of a slab. Okay, must always pass at the intersection of the axis of rotation. So this is a support point. A support point on a slab is an axis of rotation. So yield line terminates at the axis of rotation, and then it also commences at the intersection between axis of rotation. So these are some of the properties of yield line. So based on the yield line formation on a slab panel, the loads would then be transferred from the tributary area associated with the yield line to the beams adjoining that slab. So this will be done by STAAD intelligently for you using the floor load. So look at how it is done. So in our own case, we want to transfer the load from the slab. The load from the slab is 2.5 kilograms square. So you define 2.5 minus 2.5. Remember, it's acting downwards. You now define the location in space. If I want to apply on this slab, the y coordinate here is what? 14.9. The x coordinate is what? -1. The maximum x coordinate is what? 3.93. Note that what you see here when you hover your cursor around the joint is, you will see the node number as well as the x, y, and z coordinates of each of the joints. So the z coordinate here is -1. And the z coordinate here is 4.254. if it's a one-way panel, you say you tick this one way. If not, you leave it. If I add, watch what happens. You see, STAAD has transferred the pressure load onto the corresponding beam. So I can do the same thing on all these slab panels. In fact, it is very easy for you to define the boundary of the entire slab panel and then put the pressure load, and then STAAD will automatically transfer the load to the corresponding beams all around the boundaries of the slab. So that's what I'm going to do now. So I can modify this automatically, edit. I'm just going to assume that all the panels are two-way. Now, the minimum S coordinate here is -1, and here is 28.235. Z coordinate here is -1. Maximum Z here is what? 10.277. Change. Look at that. Very beautiful. So STAAD internally determines the corresponding yield line pattern and then applies it to the beams. So that's fine. So this is the roof slab dead load on the roof beams. We proceed. The roof beams are also carrying its own self-weight. We have calculated that. The roof beam finishes plus parapets. So we are assuming that the roof beams have some finishes. They could install ceramic tiles around it, and then you also have parapet walls. Let's look at the architectural design. Okay, so these are parapets. It is a very high. Usually you're supposed to calculate this correctly, but for purpose of our analysis, we're just assuming the 1 kN per meter on all the roof beams. You're supposed to calculate this based on the specific of block work and then the height of the parapets to determine exactly the loads. So, but we are assuming 1 kN per meter for the purpose of the analysis. So we create it. It's called roof beam finish. Here you add a load. You call it. You go to member load, distributed load, and then -1. Okay, make sure it's in the Y direction, global Y. Okay, add. Select all your beams. Once you don't add, it's question mark. So select all your beams, select the load, and then assign to the selected beams. Okay, you're fine. Very lovely. So these are the roof beam finishes. So all the beams are assumed to be carrying some kind of parapet for purpose of that. So, and finishes, we assume that the clients, would also put in, so you don't have just concrete beam, there are some finishes that are around the beams. So this is the beam finishes on the structure. Let's move to the next load on the roof level. So roof slab dead, we've done this. Roof beam finishes, we've done that. Okay, so imposed load. So this is roof slab imposed load on the beams. If you look at what we had created initially, this is roof slab dead load on the beams. Roof slab imposed load is taken as 0.75. It's gotten from the code of practice BS 6399 part 3. BS 6399 part 3 specifies that where you have only access for maintenance on the roof structure, the roof imposed load must be taken as 0.75. So we go to load case, add roof imposed load, create floor load minus 0.75. Okay, we're going to define it the same way we have defined the previous. Minimum S coordinate here is -1. X coordinate, okay, so -1. Maximum S coordinate here 28.235. Y coordinate is 14.9. Minimum and maximum is the same because it's a plane. Okay, this is on a plane, so